Today we're going to move on with our study of powers, and we're going to look at powers that can be written using rational exponents. In order to investigate and get some idea of how this connects to other concepts, I'd like you to take your calculators and try to enter the following powers into your calculator and evaluate them. In order to do this, in case you're not sure about with your calculators, we would enter 25, and then you should have either a y to the x button or a little hat button. Then you'd enter the value of your exponent, which is 0.5, and the equal sign. So take a moment and try this now. What do you notice about the values that you're getting for each of these expressions? Square root of 25, we got 5 as the answer. 16 to the 0.5, we got 4, we got 3, and we got 2. Now I've kind of given it away as I've been talking to you here. What do you notice about the answers that we're getting for each of these different questions? Hopefully you're noticing that the generalization that anything to the 0.5, we're getting the same answer as we would have if we just found the square root of the value. Something else I want you to see is that x to the 0.5 can be rewritten using a fractional exponent, so using x to the 1/2. Furthermore, if we want to connect that x to the 1/2 to the square root of x, I want you to think back to the vocabulary that we used a couple of days ago when we did radicals. Whatever was inside the radical sign was the radicand, and the little number that was sometimes written out there, although it was only implied in the case of a square root, that was called our root index. For any type of square root, we said that our root index was 2. We didn't write it in because it was a common root that we would find. Notice that the denominator of the fractional exponent is the same as the root index were we to write it in. Let's consider two other small examples just to make sure we have this concept in place. If we consider 16 to the 0.25, we could of course do this with our calculator. In the future though, I do want you to be able to rewrite it using a fractional exponent. So hopefully we can see that 16 to the 0.25, I could rewrite that as 16 to the quarter. Now using the ideas that we had on the previous page, we said that whatever the base of the power was became the radicand that we have in our new radical form. And we also mentioned that the denominator in the fractional exponent became the root index. We have the numerator there as a 1. If we want to, we could kind of put that outside if we wanted to make sure that we were consistent in placing every single thing. What I'm really interested in doing right now is evaluating this radical. If you guys think back to when we just had square roots, square root of 9 we'd say was 3. This is just a bit of an aside in terms of our thinking. The question that we ask ourselves when we're trying to evaluate the square root of 9 is what number multiplied by itself twice gives us 3. Of course, it's that little root index that's telling us how many times we're looking for it to be multiplied by itself. When you're trying to evaluate the square root of 16, even though it's not written in, we know there's a little root index of 2, and so we ask ourselves the question, what number multiplied by itself twice gives us 16, and that of course is 4. Think about the question that you would ask yourself if we're trying to find the fourth root of 16 in this particular example. Hopefully we can see that the extension would be what number multiplied by itself 4 times gives us 16. If you think about it for a bit, hopefully you'll see that 2 is the answer. 2 times 2 is 4, times 2 is 8, times 2 is 16. If I want to, I can carry that 1 down, but of course it doesn't change the value of our response. Okay, I would like you guys now to try 32 to the 1/5. Pause the video here, try to rewrite it as a radical, and evaluate it from there. Just like we said in the last example, hopefully we can see that the power base becomes our radicand. The bottom number, the denominator of our rational exponent, becomes the root index. And if we really wanted to, we could rewrite that numerator out here. Now we have to ask ourselves the question, what number multiplied by itself 5 times gives us 32? The answer is 2. If I really want to continue with that 1, I can. and that's what we get. Here are some other questions I would like us to try to evaluate. Copy them down, give these 3 questions a try, and check back in when you have a possible answer. I think the most important thing for us to check out here is to think about the questions that we're asking ourselves as we evaluate these expressions. So, cubed root of 27, what number multiplied by itself 3 times gives us 27? The answer is 3, because 3 times 3 times 3 would give us 27. That would be our check. Take a look at the next one. Now, this is an interesting situation because the radicand here in this situation is a negative value. I'm going to tell you that that's okay in this situation. That does not make this just a complex number. This can also have a real value assigned to it when we evaluate it. And I want you to think about why that may be so. I want you to pause the video for a moment and discuss with one another why you think that this is still a real value and why it can be evaluated. Hopefully we'll see, after you have had your discussion, that the root index here is 3, so it's an odd value. So we're not looking for what number which multiplied by itself twice gives us negative 27, a negative value, which would be impossible. We're looking at a number that multiplied by itself 3 times would give us a negative value, which is completely possible. If we were to take negative 3 times negative 3 times negative 3, we would get negative 27 as our answer. That's why negative 3 is the cubed root of negative 27. Take a look at the next one. What number multiplied by itself 4 times gives us 16? The answer is 2. Evaluating that power, we will get 8. So how did you do? Evaluate yourself and see how much more practice you think you need. So let's practice a little bit more rewriting powers as radicals and then evaluating. Let's try these ones out on your own. Pause the video and we'll take them up together in a moment. First one we have is 49 to the 1/2. We said before that the base of our power is the radicand in our radical expression. Notice that the denominator here becomes the root index. The bottom number goes out, BO, and we have an exponent 1 because of the 1 that is up here. Square root of 49 is 7. If I wanted to write the 1 in, I can, but really it just makes it 7. Let's take a look at this one. We've got 16 as the radical. Our denominator becomes our root index 2. We don't really need to write that in, but there it is in case you want to see it. The square root of 16 is 4. We still have the cube to contend with, and we're going to get 64 as our answer because 4 times 4 is 16 times 4 is 64. Notice that the brackets here show us that the negative and the 8 are both part of our base. That means they are both part of the radicand. The denominator here is a 3. That makes it the root index, and we've got the 1. Notice that it's completely possible to evaluate because the root index and the denominator are both odd values. So that makes it doable. The cubed root of negative 8 is negative 2. Here are just a few more that I want us to try. I want to make sure we have this concept down pat. Try writing these as radicals and then evaluating them. Notice in this situation we also have some negative exponents, so you need to bring in the ideas that you had last day. So give them a try, please. Now that you've had a chance to try them, let's take them up. First one is pretty straightforward, I'm hoping. The radicand, is going to be 27, just like the base of the power that we have there. Hopefully we all know now that the denominator in the fractional exponent is going to become our root index, and that the little number that's on top just stays outside as a power. Let's evaluate what's inside the radical, cubed root of 27. What number multiplies by itself 3 times to give us 27? The answer is 3. And we have the 2 to contend with. We're going to get 9 as our answer. If we take a look at the second one, notice that our exponent this time is written as a decimal. In the future, when we're handling these types of situations, I do want you to change that exponent so that it is a fraction. The expectations of the course mean connecting our fractional exponents to our radicals. So it's not enough at this point, now that we've involved ourselves in a little bit more of the thinking, to actually just use our calculator. We won't be looking for that in a test or an assessment or an assignment or in class. I want you to be able to convert this, first of all, to a fractional exponent. So I'm hoping we can see that negative 0.75 is the same thing as negative 3/4, and then to use our rules for changing it into a radical. Before we can change it to a radical, we want to deal with that negative exponent. Yesterday, when we talked about negative exponents, we said that we could rewrite them as the denominator with a positive exponent. So we'll do that once again, and then we'll change it so that we have our radical. The denominator of the fractional exponent becomes our root index. There we have the 4, and we have it cubed. The fourth root of 16 is 2 cubed. So I have 1/8 as our answer. Now that you've had a chance to see how we did that one, perhaps you'd like to pause again and try the last one. Okay, this is going to be done much the same way as the previous one. 1/27 to the positive 4/3. Rewrite it as the cubed root of 27 to the 4. And 1/3 to the 4, which is 1/81. Awesome job, guys. Hopefully you didn't have too much trouble with that. Here's the last question that I'd like you to try here. I would like us to simplify and then evaluate this expression. So we're going to use a lot of the ideas that we learned today, pulled together with some ideas from yesterday. First thing I would like us to do is to rewrite them so that we're all dealing with powers. So we'll notice that we have the square root of 8 here. I don't really want to leave it like that because I can't use my power rules if it's left in that form. So I'm going to copy down to the x to the 5/6, and I want to change it and rewrite the x, or square root 8, so that it is now a power. So it is a square root, so our little root index is 2. I can rewrite a square root 8 as x to the 1/2. So 8 to the 1/2. In the numerator, I have those two terms that are multiplied together, and then I have 8 to the 5/3 in the denominator as well. Thinking back to how we reviewed our multiplication of powers, we have a power here that's got a base 8. We've got a power here with a base 8. When we're multiplying two powers with the same base, hopefully we can remember that we add those exponents. So in this situation, we'll notice that the exponents have different denominators, so we might need to do a little bit of work here. So when we're multiplying our two powers, we add our exponents. So I have 5, 6 plus 1/2. Over in the denominator, I have 8 to the 5/3. Now let's go back and consider this. If I had 5/6, 1/2, I could rewrite as 3/6. Oh my goodness. I could rewrite as 3/6. Thinking on the side here, I'm going to get 8 to the 8/6. I could also rewrite that as 8 to the 4/3. So we have 8 to the 4/3 divided by 8 to the 5/3. Our other rule that we had for dealing with simplification of powers was when we have two powers with the same base and they're divided, we would subtract exponents. So 4/3 minus 5/3, excuse me for having to bring this up here, we're going to get 8 to the negative 1/3, and then from here we could try to rewrite it so that we no longer have a negative exponent, 1/8 to the positive 1/3, or 1/cubed root of 8, which is just like a half. Boy, that's a lot of different steps, but they're all steps that I'm confident that you know at this point. It's just tying them all together and making sure that you can do that. So let's move on, and I will give you some home practice questions. When I'm back from my meetings on Monday, we will definitely take up any of these problems that you may have had difficulty with. Here are the home practice questions that I would like you guys to try. They start on page 229. It's that section of the work that we're looking at. Questions number 1 to 3, I say to look over. If I were in class today, we would probably be talking them through and just making sure that we understood them, maybe doing them orally. I want you to use your good study skills and to be able to judge yourself. If you feel like this stuff's hard, then perhaps you need to write down some of questions 1 through 3 and practice and build our skill level up. If you're finding this fairly easy, then probably just looking over the questions and making sure you understand what you would do would be appropriate there. I do want everyone, however, to do these questions, numbers 4, 5, 6, B, D, F, 8, 10, and 18. Those should provide you with enough practice to ensure that your skill level will be what it needs to be in order to be successful in the rest of our unit. Good luck, everybody. Please make sure you have your questions ready for next day so we can start off with addressing any needs that you might have. Take care.